We've looked at how significant figures pertain to individual measurements and values, but what if we're trying to do some calculations? It won't surprise you that there are protocols for this. We have two major calculations that we'll be working with. There's addition, subtraction, there's multiplication, division, and I'm going to talk about those in the opposite order. So this is a video about calculations with significant figures. So first, multiplication, division. And I'm doing this one first just because it's the simpler case. If I multiply two numbers together, or divide, the answer needs to be rounded to the same number of significant figures as the least precise value. So I need to match the least precise value. I'm going to do this by example because it's a whole lot easier, I think. So if I take these two numbers, 2.50, and I want to multiply that by 8.000, I can do this. So the first value, 2.50, this has three significant figures. The second number, 1, 2, 3, 4, the zeros are significant because they're on the end. We talked about just how that works, so this has four significant figures. 3 is less than 4, so when I get my answer, I need my answer to have 3 significant figures. That's my less precise number. Alright, 2.5 times 8, that is 20. And I need this to have 3 significant figures. 20.0, 1, 2, 3. That's how I'm going to write this number. I'm going to do another one. What if I have 2.0 times 0.008? Sticking with 8. 2.0, this has 2 significant figures. 0.008, leading zeros are not significant, so this has 1 significant figure. Which means when I come up with my answer, I need my answer to have 1 significant figure. I do this math and I get 0.016, but I need 1 significant figure. So I'm going to round this thing 0.02, and now I have 1 significant figure. That's multiplication, division. You can practice these a little bit. Definitely worth doing, but hopefully that's not too bad to figure out. We are just saying 4 significant figures, so the answer has to have 3 because that's the smaller one. 1 significant figure, 2, so my answer can only have 1. That's what I'm doing for multiplication and division. I'm counting my significant figures. So then addition, subtraction. This one's a little bit different. The answer here has to match the least precise place value. So what that means is that I need to line up my decimal points and cut off in the same location. Maybe I'm adding, let me get a little bit of room. Maybe I'm adding 3.141, and I want to add 0.02. So I'm going to stack these up so that the decimal point lines up. 3.141, 0.02. This first number is good to the 1,000th place. The second number is good to the 100th place. So I'm going to draw a line right here. That's where I'm going to have to cut off. Now I'm going to do the math anyway. So I'm going to get my 3.161, but I need to cut off at this line. So this is going to round to 3.16. We do have to pay attention that this is a rounding, not a truncating. So let me show you what I mean by that. What if I did 8.24 plus 1.118. I'm going to again stack these up. 8.24, 1.118. I'm adding these up again. Here's my least precise position, right? I've got 2 digits after the decimal. This one's got more than 2. So I'm going to cut off right here. I'm going to do the math as though I don't care about significant figures at all. So 9.358. And now I need to round it at this line. So this one's going to be 9.36. I'm not just cutting off. I'm rounding. The 8 in the thousandths place tells me that I need to round up. That's addition subtraction. And that's really it. We do have a couple of other operations that we might work with. So like we could work with exponents and square roots, which I guess are still exponents, and sine and cosine functions and things like that. But that's pretty specialized. Addition, subtraction, multiplication, division, those are the ones that are more necessary to know.